And please can I welcome the moderator for this session, Boeree. She is a science communicator and told us earlier that you are also a former professional poker player. So it's such a shame that we're not going to be talking about that, but I think safety is probably a more appropriate topic. So welcome, Liv, and I'll pass on over to you.
Thanks, Alice. Yeah, it's a real pleasure to be moderating this panel. AI and specifically intelligence has been just a topic I found fascinating for a very long time. And, you know, it really feels like we're at the cusp, the juncture of something potentially incredibly exciting for the future of humanity as AI systems become more powerful and more capable and hopefully able to help us with things. But of course, with great power comes great responsibility. And that's why it's so crucial that we make sure that the AI systems that we develop are done safely and in a way that will create the maximally flourishing future for as many people as possible. So it's a real pleasure to be able to talk about this topic today, and particularly to be joined by two of the leading thinkers in the topic. Joining me today are Marc Warner. Marc Warner is the co-founder of Faculty AI, which is an applied AI company that focuses on safely building and deploying AI to solve important problems. Prior to that, he got a PhD in quantum computing and was a physicist at various institutions like UCL and Harvard. I'm also joined by Jaan Tallinn. Jaan is the founding engineer of Skype and Quasar, and he was also the co-founder of the Cambridge Centre for the Study of Existential Risk and also the Future of Life Institute. So really two leading thinkers. And I guess to get this kicked off, let's start with some definitions. Perhaps, Marc, you could start with this. What is AI safety, and what's the difference between narrow AI and general AI?
Yeah, that's probably a very good place to start. So it's worth, when you're thinking about kind of AI, discriminating sort of two categories. There's the things that we can do right now, which are, you know, solving relatively constrained problems very effectively in narrow domains. That's narrow AI. And then over time, as that same algorithm is able to solve different types of problems, it becomes more general. So a very good example of this is like when when they first Deep Blue, IBM used Deep Blue to beat Kasparov at chess. If you took the Deep Blue algorithm and tried to make it play Go, it wasn't in any way effective. So that was a very narrow system. But if you take something like AlphaGo, when DeepMind eventually beat Lee Sedol with their algorithm AlphaGo, they were able to repurpose that algorithm to play various other games. In fact, it's a great chess engine. It can play other things. So it's a much more general algorithm. And so in the space of this narrow to general spectrum of AI, as you were pointing out there, it's tremendous upside, extremely exciting potential, but of course we've got to make it safe. So AI safety is really the field of study at sort of both science and engineering to ensure that algorithms do what you wanted them to do. And in the kind of case of narrow stuff, we can be a bit more specific about that. So at Faculty, we think of AI safety as the field of, at least in the narrow sense, making algorithms fair, private, robust, and explainable.
Jaan, anything to expand on with that?
Perhaps I would just add that, like, recently I've been using this model of thinking about AI. So the core of AI is automated decision making, and you can think of AI adoption as delegation to automated decision makers, and they're like they put the sort of value of delegating, or value of AI adoption becomes apparent because, like, if you're able to delegate well, you're able to increase the overall competence of your company, of your country, of your society, of the world. But as we all know, like if you delegate badly, then you might get something completely different than you originally had in mind. And also the difference between narrow and general becomes fairly obvious. Like narrow AIs are AIs that are competent in some domains, but like general AIs are AIs that you can delegate to, like in very different domains and hope to get a competent outcome. And finally, what's also important to observe is that the more in some ways the amount of incompetence that AI has, or like the domains that AI isn't competent in, is a resource. Like this is the resource that we can use to control the AIs. So like if you have AIs that are aware that there is a control mechanism, that there are humans, that there are off buttons, those AIs by nature are much harder to control than AIs that, like the Deep Blue was, that had no idea that there was an off button, so it didn't make any moves against that.
How did you become interested in AI safety in the first place? Because it's quite an unusual topic, and you're both quite early thinkers in it. So how did that start? Yeah,
my own start was back in 2007 or 2008. So I've been like quite a long time in this business. When I was gradually easing out from Skype and was looking for like new things to do that might be challenging, a friend of mine even asked me like, so what are you gonna do? How does it feel when you have your life's work done at such an early age? And I was like, wait a minute, that's like that's very unflattering way of putting it. So I was really looking for what are the important things in the world, and then I stumbled on the writings of Eliezer Yudkowsky, an AI safety researcher, young AI safety researcher in California. Now he's a little bit less young. And he was like making this really persuasive argument that, look, AIs are going to be great, but like the default outcome from AIs is not going to be good. We actually need to put effort in order to make sure that increasingly competent machines are going to be compatible with what we as non-machines want from the future. And I found that argument very persuasive and was like, okay, this seems to be the most important thing in the world that like almost nobody back in 2008, 2009 was paying attention to. Is like, why? That's a very curious fact about the world. And then I started kind of digging deeper and deeper and deeper and kind of getting more and more people involved in this. And now, like, yeah, a decade later, there's like a whole ecosystem and more people kind of trying to put in their efforts into this topic.
Yeah, I can personally attest to Eliezer Yudkowsky's writing. That's also largely what got me interested in the topic too. How about you, Marc?
Yeah, very similar. I mean, I think I struggle to remember whether I read Bostrom before or after the
Nick Bostrom, for everyone.
Yeah, Nick Bostrom's. I think he wrote some early stuff on this as well. But I, like Jaan, around the same time, found it very convincing. In fact, it was how Jaan and I first met, I think, quite a few years ago when he was doing the. Actually, no, sorry, that's not true. It was we met through MetaMed. But yeah, we've been like, this community is now growing up around it, and there are real opportunities to work on AI safety, partially because of, actually a great deal because of the work of Jaan. For anyone out there that's interested, there is funding available. It is now a sort of research field that people can actually go into, which is transformational at places like faculty, but also at, I think Berkeley has a big center and a bunch of other places across the world.
Yeah, I'm right now in the middle of wrapping up a $10 million grant round at the Survival and Flourishing Fund that primarily goes to AI safety.
Well, we'll touch a little bit more about what people can do later on. Before we get into that, can you, perhaps Marc, if you can handle this one in the beginning, with narrow AI, there are certain examples that people are already starting to become concerned about. Could you talk us through some of those, and any examples that are particularly good or bad from a safety perspective?
Yeah, totally. So the truth is, at the moment, quite a lot of companies don't focus too heavily on AI safety. So there is a bit of a tendency to sort of present safety and performance as almost a dichotomy, where you can have safety or you can have performance, and you have to choose. And of course, we know AI is just like any other technology, and in like, take cars, that our cars are both faster and safer than the Model T Ford was. And so this kind of dichotomy between safety and performance just simply isn't true. You just have to demand both, and that is totally possible. So without wanting to beat up on anyone particularly, I think one good example perhaps was the work that we did with the NHS. So over the last sort of 18 months, faculty helped the NHS to understand and predict how many COVID cases there were in various hospitals. And then from that, of course, you can figure out the demand for medical equipment, things like oxygen, ventilators. And you can also, that's sort of when things are getting bad and when things are kind of calming down, you can sort of figure out how to reopen elective care with confidence. Of course, I should say this doesn't involve any personal data, because it's a very system level thing that you're looking at. You just want very aggregate numbers. And of course, inside the NHS, any decisions around important clinical matters are always made by clinicians. So in this case, it was our algorithms were sort of giving them the best estimate from the data, and then the human decision makers take into account all the context that they know about the system, about the policy, about how it's faring in other countries, and bring all of that nuance to bear in actually, deciding exactly what the right thing to do at any given time is. But of course, what inevitably happens is that smart decision makers end up asking a bunch of questions couched in the language of the problem they're trying to solve that are ultimately AI safety questions. Like, oh, you're telling me this is going to happen. How robust is that? You're telling me that this is going to go up. Why did it go up there but not there? I mean, that's ultimately an explainability question. How do we ensure we get the best outcomes for everyone? I mean, kind of fairness questions. So we were able, actually, because of our sort of heritage in basically the very philosophical and academic version of AI safety, starting out from kind of like thinking about super intelligence and stuff, but then bringing that down to what does that mean in terms of like tooling that we could build for data scientists now. We were able to incorporate a bunch of that so that it really could give like decent explanations for this prediction is going up because of these things in like, the number of patients in the hospital last week, the trends in other hospitals in the region over the last few weeks, these kinds of things. And so I think of that as a nice example of somewhere where important application, but safety critical, and safety being built in from the very start.
So, yeah, you think that there isn't necessarily a dichotomy between safety and progress in narrow AI. Would you say that generalizes to AGI as well?
Well, I don't think I'd quite say that. So I'd say that if we don't insist on safety and performance at the same time, we will inevitably only end up with performance, for a while, until the like bad things
catches
happen.
up.
Exactly. So you'll get a period of it looking really good, and then bad things happening. So I guess my statement is, it is possible. Like, don't believe the sort of narrative that these two things have to be done independently, and you can either choose a fast car or you can choose a safe car. You can just choose, like any modern car, significantly faster and significantly safer than cars 50, 100 years ago. And so we have to insist on both. It should be a sort of principle of how we operate, is that we insist on safety and performance at the same time, rather than letting people get away with one or other.
I mean, I think that's kind of what I understand the general AI safety concern to be, is that it sort of breaks down into two problems. You've got both the technical issues, the technical difficulties of creating it, and then you've also got the governance issues. So perhaps we can start talking about the technical technical AGI problems first. Jaan, what do you have to say about those?
Yeah, I mean, first of all, I do agree with Marc that like if you're going to look at the safety issue from far enough, you basically see like the trade-off is between short-term, following your short-term interests, just making money quickly, versus like long-term, making sure that like you will still be there, and the world will still be there, like in 20 or 40 or 100 years. So and like you kind of lesser term. Stuart Russell has this like great example where he says that if you think about it, nuclear power industry sort of kind of killed itself by downplaying the safety and not investing enough in safety. So that's like and his kind of hope is that the AI industry can kind of learn from those lessons. So when it comes to technical safety, I mean, it's a very wide research field by now, and you can kind of make various divisions there. Like one interesting division that I've been making is the safety of deployment versus sort of principle, like fundamental safety or safety from first principles. So quite often there is like a bit of a tribalism or at least debate between so-called short-term safety and long-term safety, AI safety people who really should be kind of in the same boat. But the I think important difference there is that the short-term AI safety people tend to think way more about deployment issues. So thinking about, okay, what are the AI systems that we already have, and how could we deploy things like self-driving cars and face recognition and whatnot in a way that doesn't kind of completely disrupt the balance that we have in society, and hopefully will make it better. And then like the long-term safety people try to think like sort of more from the first principles, like AI is not a static target. It keeps moving. So what are the things that we kind of can and should be doing in preparation when we are in the next 10, 20, 50 years going to introduce like ultra competent decision makers into our society that are ultimately alien. They do not share the same values by default and same makeup, same kind of things that we have humans have developed intuitions about. So like so necessarily you have to think more generally about like how to constrain very competent decision makers. And turns out this is a super hard problem. And I do think there's like a value in the some overlap between people who think about how make deployment safe now versus people who think about like where the AI could ultimately go, what are the ultimate limits, and how basically think in terms of ultimate security, have like security mindset, think about what are the worst things that could happen and how to kind of cut off those tails.
Marc, do you have anything to add to that?
Yeah, totally. I mean, I totally agree with Jaan. I mean, I think it's a very good thing for the world that people are exploring both avenues. Really, I think it's unclear to me exactly which one turns out to be most productive. And in some ways, I could mount a strong claim that it's only by thinking from first principles you're going to have the requisite robustness to really make things secure. That seems like a sensible argument, but it's very, very hard right now to know what are the ultimate technologies around which general intelligence will be based. And we have some inklings, but I don't know that anyone would make a particularly strong claim that they can can stand behind. And so if you take that approach, you are vulnerable to just kind of working on things that turn out to be somewhat irrelevant. Whereas you could say that a lot of scientific progress appears to have come from working on very concrete problems. So just the sort of things that are right in front of your face and solving those problems, and then building a kind of like very grounded edifice of knowledge that over time will enable you to tackle the bigger questions. You know, things like thermodynamics were all tinkerers first before you got to the Maxwell's and co unifying. And so I think there's a very good argument that a productive strategy is, and this is actually the one faculty takes, is starting with the safety problems right in front of our face, and then kind of working up to the more complicated ones. But I think, as Jaan says, the critical failure that we have to avoid is tribalism and not like sharing best practices between the two. That would be a total tragedy, because it's very likely that actually there'll be insights from both that can kind of steer the field usefully. So yeah, I think that's an important, like the collaboration there is going to be important.
Yeah, absolutely. I think one great example that people in the kind of long term from first principles approach give is like the space travel. We didn't kind of like start building like rockets and then see how we can kind of steer them by experiments. We first had people like Tsiolkovsky figure out what the fundamental equations of gravity are, and then kind of build things around from first principles.
But of course, that isn't quite true, right? Because we did actually build rockets.
Well, yeah, so like I think like in the end,
so there's a nice tension.
There isn't like kind of like I think at the end you have to have like a portfolio approach and have like one sort of first principles informing your experiments and vice versa.
Totally.
I imagine there are people listening to this who, you know, while they agree, okay, yes, it in theory would be a very difficult problem to solve, they are still skeptical that such a thing as superintelligence could ever exist. You know, like quite often people are like, well, it's just impossible. You can't, like, we don't understand human intelligence enough. Like, there's no way we could just build something that's even smarter than us. And what would you say, first of all, to people who don't think that it's an issue in the first place? It's an impossibility.
I get that question a lot. So it's like, one thing is that, like, how sure are you? Like, would you be willing to bet the children of your lives on you being right on that statement? And the other thing is just look at like humans seem to be a proof of concept. Evolution had no idea what it was doing. It was just tinkering around. And in fact, like a lot of the current AI research, top research, seems to be like very evolutionary in that sense, that we are just like throwing more and more compute at black boxes and seeing like hopefully something useful and safe would fall out from the other end.
Actually, Jaan, on that, I do think it's useful to sort of there's one. I think it's better to talk about these big models as like dark gray boxes or something.
Mm-hmm. Sure.
I don't want to give people the impression that it's fundamentally impossible to see what's going on inside them. Like, ultimately they're algorithms with many, billions, even these days, trillions of parameters, which is incredibly hard to interpret. But they're sort of dark gray boxes in the sense that we do actually have all the information. And so in principle, there is a very productive study in trying to untangle exactly what's going on and why. And, it kind of gives us hope for making these things safe in a way that if it was truly a fundamentally like black box, as in, there was nothing you could ever do, then I think that might give people a somewhat negative impression of the possibility of actually solving some of these problems.
Yeah, I think that's an important correction. In fact, like just a few weeks ago, I led an investment in Anthropic, which is kind of like predicated on that kind of research. So it's like I do put my money in betting that these are gray boxes, not black boxes, indeed.
We have about 10 minutes left. So if anyone in the audience has any questions, please type them into the chat box and they'll get sent through to us. So one of the stats I remember hearing is that for every $1,000 that is spent on AI progress, approximately $1 is spent on safety. I hope that ratio has improved somewhat. Do you guys have any insight on what the current ratios are? And more importantly, what do you think the ratios should be?
Yeah, and I don't know, you probably have a better overview of other parts of the ecosystem than I do. I can talk a little bit about faculty.
Yeah, I think I would still, I think that 1 to 1,000 is still roughly right, but it really depends on how you delineate. Like some of the work is kind of like, as Marc pointed out, like in the interest of both things. So it's like, yeah, how do you gonna do you just think about safety work that's not really getting done without supporting it separately from the competence work, or I also counting things. But yeah, it's definitely many orders of magnitude difference. And the reason, like, although like the safety funding has increased a lot, also so has the AI competence. So it's like competence research. So or their budgets. So I think the ratio perhaps hasn't changed a lot, even though like both fields are like very growing a lot. Also important that it's not at this stage. It's not even clear. Basically, I think there's a bigger bottleneck in AI safety when it comes to like having like good ideas and good talent than there is. And I again just finishing my latest AI safety funding round. It seems to me that there's like a shortage in terms of ideas, projects, and initiatives when it comes to AI safety, rather than just money now. I think the money has available funding has just grown quicker than the field has been able to keep up.
So it's almost more of a sort of brain power and attention problem.
Yeah, we just need
interest problem,
insights.
as opposed to a money problem. Yeah. I guess a lot of people, if you're a young smart developer, it sounds more exciting to be working on progress perhaps than safety. But
yeah, there are certain like more opportunities to work on that. So I think in some ways it's kind of like either the AI safety field should do some more homework and figure out how to kind of accommodate more smart people into this, because the topics are just insanely interesting. I could make an argument that the AI safety as a field is just way more interesting than AI capabilities. But like because of the existing size of the fields, like comparative, that is just is much easier much safer to think about like your career as a AI capability researcher.
To dangle a carrot, can you give an example of perhaps a really interesting philosophical question or a game theoretic question that a researcher could be working on?
So like fundamental things about morality, I think things that like, as I said, like in the long run, you kind of like, you might want to think more about from first principles. So like really interesting questions like what does thinking about morality from first principles look like? We know that human morality is grounded in game theory. Ultimately, like tribes that were able to better cooperate, they were more competitive than the tribes that weren't. So like there was like instrumental reason to be moral. Now think about like how does that observation generalize to agents in general? When we add like kind of non-humans into mix, aliens, AIs, superintelligences, do we still have some kind of like moral principles that will survive this kind of thing? I find it just like super fascinating when you start thinking about those.
And I do think it's really interesting that it is sorry, I think it was the moderator at the start's point about ethics. It is becoming a sort of essentially a mathematical discipline, right? The Jaan's question there can be tackled as a kind of, has to be tackled eventually as a technical field of study. And so it's this sort of wonderful, interesting discipline where you get to ask very big questions, but you need to solve them mathematically. And to your point, Jaan, just to sort of encourage people, while AI safety is smaller, that does, has a sort of like some slightly more risk associated with it, but it also means that the potential to contribute powerful insights is just much, much higher. I mean, one of the reasons, you know, as Liv said, I was a physicist by background, and it really is. I mean, physics is just a much, much more noticeably more mature field when you're working in it, and the ability to have significant breakthroughs in my field, which was like condensed matter physics and quantum information, is just harder. Whereas in machine learning, it's clearly easier, and in AI safety, it's, I think, even easier to be a very incredibly important figure in driving that forward. So that is maybe a sort of potential opportunity for an incredibly brilliant young person.
Yeah, it's not inconceivable that like a few mathematical insights could save the whole civilization in the future.
That's quite a responsibility to put on people's shoulders.
Mathematicians.
We just need the formula.
Question from the audience from David Wood. What are the most significant concrete results from the increasing amount of money that has been applied to AI safety?
So like one thing that kind of immediately comes to mind is a kind of difference between inner alignment and outer alignment. This is like a concept from AI safety community. It's kind of, I think it's a little bit technical and difficult to explain, but it's really fundamental thing. Like one thing that you can observe that humans didn't really have, well, evolution was sort of training humans. It didn't really have alignment problem. In the kind of traditional sense, because it was just selecting for the thing that it wanted, yet it still didn't get what it wanted. So like the argument there is that like there was like no outer alignment problem, but there was an inner alignment problem. Like humans, as we were built, we didn't really sort of internalize what the evolution was trying to do, which was like creating better and better self-replicators. We kind of ended up with a hodgepodge of heuristics, like eating good, sex good, like and sort of yeah. Anyway, like fat good. so it's and now we just like kind of try to maximize those. Like a really good thought experiment you can think about, like if you have like a group of people around the table and they put the button on the table, saying that like if anybody who presses that button will have half the next generation with their population with their genes on it. That would be like the thing that evolution would be like delighted if you pressed, but like people would probably go like, that's a really strange thing to do. Like, why would you care about that button? So it's like that's an illustration. Like there is an inner alignment failure when it comes to, and that's a concept just from the AI safety community, like fairly recent one at that as well.
So we've only got about 2 minutes remaining. Perhaps in that time, could you guys both sort of give a call to action to both the tech, anyone in the audience who is in charge of a tech company, and also to developers or mathematicians or whoever in the audience? What resources can they be looking at in order to learn more and to get involved in the field?
So I would just kind of mention like 2 resources that I point usually people to, like young people who think about like how to kind of maximize their careers. You should go to 80,000hours.org, and if you really want to see like what the latest discourse in AI safety is, you should go to alignmentforum.org. That is AI alignment forum.
Actually, there's one other interesting thing about AI safety is because it's a slightly weird community that doesn't totally have a home in academia. A lot of the best discourse is just available on the internet. It's not sort of taking place in long established conferences and stuff like that. So the kind of alignment.org is a great place. And then, I would pitch organizations who care about safety, at least in the sort of short-term narrow sense, talking to faculty and people who want to work on it, potentially coming to faculty as well. That's something we care a lot about, alongside using capability stuff for what we think of as important and good problems, but ensuring they're safe is just a totally critical part of that. So we'd be very happy to talk to anyone who's interested.
Brilliant. Well, thank you both so much for your time, and for everyone listening. Hopefully it's given you guys some food for thought. It's a huge topic and a very, very important one.